All right, guys, so we've got everything working the way we want. We've got motion on WASD keys. We can move around, and the camera follows us. It actually feels like we're moving through the game world, but there's not much here. We've got some texture on the floor so that we can see that we're actually going different directions. But what we want to do now is actually start to build out our game world a little bit. So let's build some terrain, again, using some native shapes. So what I'm going to do is all the different parts of the player, his hat, his eyes, all that kind of stuff, I created those as game objects that were childed to the player. So what I'm going to do now is I'm going to build some game objects to be part of the terrain. Well, the floor is the basis of our terrain, so I'm going to have them actually childed to the floor. What I want to do is I want to avoid a giant list of 70,000 game objects that are all just one huge list. I want them nested in, in parent-child relationships in a way that makes it easy to find things, and you can turn whole groups of things on and off with the active checkbox very easily. So I'm going to pick the floor, and let's create a 3D game object. I'm going to make a cube. Bam, there's my cube. So what I want to do now, let's just pull that up a little bit. So it's already squashed, and the reason why it's squashed is because since we created it as part of the floor, notice that the floor, its scale is 10 width and 10 height. So for this new cube, it's not actually cube-shaped because it's stretched in the X and in the Z dimension by a factor of 10, because the floor is its universe, and its universe has been stretched. So if we want the cube to actually be a cube, we have to counteract the stretching that the floor has happened. So I'm just going to put 0.1. That should be the opposite of 10, and 0.1 in the Z. And now we have an actual cube. What I want to do right now is I don't actually want a cube. What I wanted was something that had flat sides, because I'm going to turn this thing into a wall. So the side to side, the X dimension here, I'm actually going to take that back to, let's make it 2 wide. I want it pretty wide. So there it is. And I'm gonna kind of move it off to the side here. It doesn't need to be thick. So my Z, right now, as you can see, it's an entire unit thick. The units that we're using here in Unity are supposed to be roughly equivalent in the game world. Like if we have a 1 right here, 1 means 1 meter, give or take. I mean, there's no actual measurement inside the game world, and we could completely ruin this scale if we make our character 10 times as big. So he's 2 meters tall right now. He's 2 units tall. We could make him 20 units tall, and as long as we make everything else in the world look right next to him, then for the most part, the game will be fine. The way that Unity calculates physics and stuff, how fast are things supposed to fall, how hard do things hit each other, that could get weird. So the way that Unity wants you to kind of keep things actually in Unity units, something along the lines of 1 Unity unit equals 1 meter in the real world, so that the physics acts the way that you expect it to. And shading and stuff like that. See the shadow cast by this. If we grab this and lift it higher up off the ground, the shadow should get fuzzier. And then if we lower it down, then the shadow that we get should be sharper. So some of those kinds of things are in play here. Anyway, I don't want my my wall to be super thick, and that's going to be my Z dimension. So I'm actually going to make that, the Z is going to be super small. Let's make it 0.01. Okay, it's going to be thin. And the Y dimension, I want that taller, so let's make that like 10. Okay, now I've got myself a genuine wall, right? So Let's kind of scoot down and see if what that looks like from under the floor. Is it actually touching? I don't think it's actually touching. That's because I've got it a scale of 10 tall, but it's more than 5 units off the ground. So half of the way up, I mean, the center of it is where we're measuring from. So if that's 5 units up, then that means that the bottom, if it's 10 tall total from bottom to the top across the middle there, then that will actually touch. So let me just set the Y position to 5, and that should lower it to being just on the floor. If you're not certain, make it a little lower. So let's just move it down to, like, I don't know, 4.9. 4. We'll make it 4. So it sticks down through the floor a little bit when you actually play the game. If we go over to our player and rotate towards that new wall, you can see it. You can't see it extend through the floor. You just see it make contact with the floor. So that's perfectly fine. I like that. That makes a wall. Okay, now let's take our new wall and duplicate it. I'm just going to right click and pick duplicate. Now there's 2 of them. Doesn't look like there's 2 of them because they occupy the exact same space. So let's go back over here to the scene view. I'm just going to pull one of them forward, and you can actually see now there are 2, right? So I'm going to get a little bit of a bird's eye view here. What I'm going to do now is take the second one, and I'm going to rotate it by 90 degrees around the Y-axis. If you're not sure which way you should rotate stuff, again, you can just come over here. It's like, are we rotating around X-axis? Okay, turning the thing sideways is not what I had in mind like that. So I'm just going to go back to 0. Around Y-axis, yes, I want to have a wall that goes sideways to this. So 90 degrees, right, is a perfect sideways angle. So I'm gonna now just kind of, if I grab the individual arrows here in my, let's see, I'm on the move tool here. And if I grab the individual arrows, I can move it in a direction without messing with the other direction. So notice I've grabbed the Z arrow here, and the Z is the only number that changes when I slide it back and forth there. So Z changes, Y stays perfect at 4, and X stays, I guess, perfect at 2.6 or whatever. Okay, so let's kind of get above the thing here, and I want to actually kind of try to make a little bit of a building here. So I'm gonna slide this out to the back, and I'm just kind of eyeballing this. You could probably get real mathy and precise. I see a little crack there, so I'm gonna slide this back into it and pull it back. Try and make a decent little joint right there. Okay, and then I can go back to my first cube and duplicate that again. Duplicate. Where are we? There we are. And then pull that across here, and let's again, let's get a bird's eye view, kind of make them lined up. All right. Okay, so I think that first one could probably come out this way, just a hint. Okay, so you can be as picky about this as you want, right? Now, these are called cube, and that's a horrible name for things. What I think I want to do now is, instead of having all 3 of these cubes just be attached to the floor, let's select, I'm holding shift and picking, so I can pick the top one and hold shift to go to the bottom one, or I can click the bottom one, hold shift to and click the top one, and it selects all 3 of them together. And I'm going to right click, and let's create, I'm doing this backwards. Don't do that. Instead, I'm going to go. Yeah, I should have done this from the beginning. I'm going to create an empty game object. And I want to make sure it's attached to the floor. Let's see. And I'm going to name it building. Right? And then I'm going to have all my items attached to it. Now check out this first cube. See, it's at position, it's -2 and minus 0.4, right? Well, I'm going to take all of those and drop them into the building so that they're all childed to it. Now, they stay exactly the same thing, but the building is actually, I'm okay with where this is positioned. So the center of the actual, the building game object doesn't actually have any place where it, like it doesn't have any mass. It doesn't sit somewhere in particular, but it still has to have a position in space. And the position that it has is right here. And that's sort of where my back wall is. So I'm okay with this. For some reason, it's measuring that it is at a Y position of -28. I'm pretty sure we want that to be at a Y position of 0. Now, when I change this to 0, it's going to move my walls up 28 units into the air. And my cube right now is at 32 units up. Remember, we had it at 4 before? So what happened was when I created this empty game object, it put it at a super low number right here. And let's just type in 0, right? And you can see here, it's moved the walls super far up off the ground. Let's get a view of that, right? So yeah, those walls are way up in the air. This is not what we want. So cube number 1 is at 32. We want it at 4, just like it used to be, 4. Cube number 1, again, 4. And cube number 2, 4. So what I probably should have done was make the 4. I made it 0. That's not right. 4. Okay. Okay, good. So what I probably should have done was actually create the building empty game object in the first place, and then start adding these to it so that they all could be positioned relative to my point in space that is supposed to be the center of this thing. At the moment, my point in space is actually connected to the back wall. And because I'm not going to be super picky right now, that's fine. I can, I just want to make sure that I can actually still position my building so it looks like it sits on the floor. But now that I have all of those different, all my walls connected to this building game object, I can actually just grab the building game object. And if I want to change the X position, I can slide the entire building as one unit back and forth until it's positioned where I want it. I can pull it with the arrows over here, or I can manipulate I can slide the numbers around right over here in the transform position. So I've got myself a, let's do this. Okay, I'm going to do one more thing here. I'm going to take the back wall here, which is cube number 1. I started to say this earlier, but let's take these cubes, and instead of having them called cube, let's name them wall. Wall 1. Wall back. How's that? It's going to be the back wall of the thing. And this is going to be the wall 2. Now I'm going to take this back wall and I'm going to duplicate it. Duplicate. I'm going to slide it to the front, and we have a perfectly enclosed box that nobody can go in or out of, which is not quite what I want. So what I'm going to do is I'm going to change the scale. Right now, you can see this X scale is 20. That's the big dimension. So I'm going to take it back to like 9. Okay. And I picked 9 because it's just less than half. So what I'm going to do is I'm going to slide that into place so it makes contact with that wall. And we'll duplicate it again. And the duplicate will slide into place so it contacts that wall. And that leaves this tiny little sliver of space in between that we can use for a doorway. Now, I'm kind of looking at my character over here, and I'm looking at the amount of space that I've left him, and I don't like it. It's not enough space. So I'm going to change the scale here to 8. and slide that wall out just a little bit more. This one, again, change the X scale to 8 and slide it out a little bit more. Okay, now I think that building looks pretty good. Let's go in and play, and we'll take our character and walk around it and have a look at it the way that it will appear in the game. So we've got ourselves some walls. You can see I can get the seam just a little bit tighter there. That would be better. But yeah, I can go in here and walk through inside. I don't know, maybe I could make a little maze in here. So basically, what I want for everybody to do right now is go through and just start building some stuff that will be fun to have in your game world. Something that is you can some obstacles, some buildings, make a maze. Don't do anything as far as up and down movement yet. I'm going to save that for that's a little more complex than what I want to do right now. So I'm just going to pause right here for a second, and everybody go build yourself some level stuff. Have fun. I'll be right here. I'm waiting for you to come back. Pause the video, because right now I'm going to start talking like as if you had already spent a good half hour making stuff. Okay, you paused the video, you made stuff, and now I'm going to continue. So here's what you didn't notice the first time when we played through, because I very carefully didn't do this. When I'm in play mode and I walk through my little doorway here, I'm inside, and I can just walk right back through the walls. This is not okay. It's like the walls don't even exist to me. I'm a ghost. That's not good. So I'm just gonna kind of like right now, if I stay in the game's still in play mode, but if I switch over to the scene view, I can see my characters like right. Where am I? I'm actually buried in the wall. Right. This is not good at all. We shouldn't be able to have that. That's really bizarre. Okay, so now you've got some obstacles and stuff that you can interact with, and we're not actually interacting with them. So this is no good. Here's what we have to do. We have to take our player and add a rigid body to him. Rigid body is the component that makes the game calculate physics. If you run into something like a wall, then physics is going to stop you from going into the wall. You're going to run into it and collide with it. Now, all of our game objects so far have this thing called a collider. Here on the player, we had a capsule collider because we had a collider shape that we made him out of in the first place, that 3D shape. And so it's when you make that shape, it automatically has a collider that's the same shape. And so what that is just a whole bunch of math that tells the computer where the edges of your capsule are. And then if the edges of that cross with the edges of something else, then the computer can say, oh, well, we should probably handle that. And it will do some math and decide what's supposed to happen in a way that seems to act like physics. So when you bump into a wall, it's going to stop you from going through the wall. We have a collider already on our capsule, and if we look at one of the walls, we also have a collider on the wall. It's shaped like a box because that wall is just a really stretched out cube, right? So box collider is box shaped. The capsule collider is capsule shaped. Now what we need to do is on our player, we need to add the component rigid body. We don't want to be able to push the wall down. So we're not going to add a rigid body to the wall component because we don't want Unity to manipulate the position of the wall when we bump into it. We only want it to manipulate the position of our player because we're trying to walk through the wall, and the game is supposed to say, no, you can't do that. So I've got the player selected here in the hierarchy, and I'm going to go to the bottom of his inspector tab, and I'm going to add this component. Let's see. Physics, not physics 2D. That's for side scroller, kind of a 2D game. We're going to click on physics, and we're going to pick the rigid body. Now that's going to be added to him. Awesome. Now that that's there, that's pretty much everything that we need to do, sort of. Hit play. Let's see what this does. Okay. Guys, we fell down. Very first thing that happened, we fell down. If we click over to our scene view, yeah, you know what? Our eyeballs and our nose are out in front of us, and that tipped us right over. This is not good. Okay, physics is already pulling us down. And first thing that we did right out of the bat, we fell down. Not what we are after. So, take us out of play mode. The rigid body has some ways to prevent that from happening. So what we're going to do is go to the bottom of the rigid body component on our player and expand this menu, the constraints. So what we're going to do is we're going to freeze his rotation in X, Y, and Z axes. Every single axis we don't want to rotate. Now, that's not entirely true. You remember when we're using our arrow keys, or we're using the WASD, when we hit A or D to turn side to side, we are in fact rotating. And that's fine. This is not going to stop us from rotating. What it's going to stop is Unity's physics engine from deciding that we should rotate and jumping in and rotating us. So our code will still rotate us, but physics will not rotate us anymore. So that is exactly what we want, I think. So we're going to hit play and check out what happens now that we've frozen the rotation. Okay, we're not falling over. That's better. Okay, we can turn still. That's good. When I run forward, let's see. Yes, we still went through the wall. I can't back through the wall. This is a little bit weird. I'm kind of like bumping into it. This is a little hard to see what's going on. We went through the little crack. So part of what's happening is that the wall is so thin that when the edge of our collider starts to poke through it, sometimes the as fast as we're moving, which is not super fast or anything, the edge of our character sticks far enough into the wall that the physics engine is confused about whether or not it's supposed to stop us. So one of the things that we can do is go to our walls, and instead of having a scale of, this was 0.1, which got extrapolated into something close to 0.1, let's make the wall 0. 3. And let's have a look at that. So when we made that thing 0.3 right now, let's see how thick it looks. It looks that thick. And honestly, that doesn't look so thick. You can see our wall over here is very thin on this side. But the one on this side, 0.3 seems not so strange. So I like 0.3. It's a start, at least. So I'm just going to go through and set the Z thickness, the Z scale to 0.3 for all of my walls. And we will see if that fixes our little weird physics problem. So a lot of the fine-tuning that you're going to do is like in a game, how do I make weird stuff that happens in the game work? Do I need to go in and rewrite the way that Unity does physics? Do I need to write new code to handle this? Or can I do something like thicken the wall up a little bit just to make the thing work? And it's not going to really mess up my game at all. In fact, in this case, thickening up the walls, notice we no longer have that weird little crack here because the walls are thicker. It's kind of sealed it. Okay, so sometimes, I don't know, sometimes it just works. Okay, so here we come. Let's bump into the wall. Bump into the wall. Yeah, it seems to be stopping us. Right? I can run into the corner. We're getting some weird, like we can see through the wall. Oh, we went through the wall. Okay, so regardless, the thicker wall seems to be helping. I might thicken that up to 0.5. If I look side on here, I think that the wall could still stand to be thicker without feeling weird, and that might even out what we're doing here. So, guys, what you're going to need to do is make sure that you have everything working the way that you want. Mess with the thickness of the walls. Mess with where things are positioned. Maybe mess with the players. Let's see. Here we got a player motion script. Maybe mess with the player's speed. Like if you go slower, that gives the physics a better chance to grab your character and understand that he's been stopped. Just a combination of different things. Maybe you don't like how your game acts when you make him go slower. You need that speed, and you need the walls to be thin both. Well, unfortunately, that's beyond the scope of what we're doing here, because then you're going to have to go to much more technical ways of handling that. It can be handled. You've all seen games that do that and do it well. But right now we just need to get a basic game going so you get a feel for how to make this thing. So you've got some physics added to your character so he can't go through walls, and you've built some walls, and hopefully more walls than I just built right here. So congratulations. We're off to a pretty good start. Good job, guys.